I can share this explanation in the classroom later after the class over. So if you found that during this class discussion, there is something need to be discussed more, or you have question about it, you can refer to the record of this material and you can ask to me. Okay, so now I will slide show this presentation. Okay, so the names of this course is Mechanics of Materials. It will learn about how the materials behave if we apply the external loads on it. Okay? That's the main story about this course. And this course, oh, sorry, we have a limited time, just like usual. So this course, the Mechanic of Material course, is a prerequisite course for the design of machine elements for the next semester. Okay, if you don't have the competency in this Mechanic of Materials, then you will have problem in designing the machine elements, machine components. Okay. So in this course, in this Mechanics of Materials, we will develop several competencies. Okay. As listed here, that we have the properties of materials and combined stress analysis, and then stress transformation, and then failure theories. Actually, this is the series of competencies. Okay. This is the series of competencies. Okay. Sorry about this. I have problem to change my slide. Okay, so for the material properties, okay, we need to learn about several important behavior of the materials, because these properties can give us the picture about the capacity of the materials when we apply load on it. Just like you see here that we have the test standard tensile test to obtain stress and strain diagram as shown in this slide. And on this diagram, we can make interpretation. We can identify several important points, just like yield stress, ultimate stress, and fracture stress. And we can also learn about the plastic deformation, elastic deformation, and also the proportional limit, which is related with Young's modulus. All those properties will be used to evaluate the strength or the behavior of materials during loading. Okay. So then, after knowing the basic behavior of materials, then we learn about how the external loadings affect those materials. Okay. So in the static course, we already learned about several types of loadings. We have tension loading, compression loading, torsional loading. But in practical conditions, all those loads, all those type of loads can apply simultaneously. I mean, at the same time, working together. Then it creates complex loadings on the structure, on the components. Then these combined loadings create stress at every point on the components. For example, if we observe here the point of H, it has the state of stress as shown in the right side figure. Then if we are able to describe this state of stress, we will continue to the next one. That is, we will use that state of stress to find the maximum and minimum stress, the resultant of stress. Here we can find using analytical method or graphical method using Mohr circle. Why? Why we have interest in the maximum and minimum stress? Because we want to compare this stress with the strength of materials. Okay. By comparing the stress with strength of the material, then we can judge, we can tell whether the specimen broken or not, plastically deformed or elastically deformed. In order to judge whether the components is safe or fail, then we need several criteria. We call this failure theories. We have maximum shear stress. So we compare the shear stress of created by the load with the shear strength of the material. And we also use maximum normal stress theory, which compare the normal stress generated by loadings with the normal strength of the materials. Or we can use distortion energy theory. It is more complicated than the maximum shear stress or maximum normal stress, but I think it is not too complicated, so it is easily can be understood. Okay, so up to here, we will be able to design the components, the machine components. I mean, we will able to design the structure. Those competency enough. Okay. So you can modify the geometry, you can change the material, you can manipulate the loading so that you can create strong structure. You can create a strong component that can work safely. But there is one condition when we cannot do force analysis. We cannot apply Newton equation to find the unknown loadings, the unknown stress. Therefore, we need another method. We need another tools, so-called virtual energy. As you can see here that we relate the stress with the deformation. So we don't talk about the force, but we relate the stress with the deformation using the properties of material, so-called Young modulus. So this is another tools, another method, which allow us to evaluate the stress. Okay, then we will learn also about deflection. As you know that the component may be not broken, but it can have deformation. And when the deflection is severe, too much than what we plan, than what we design, then we consider that this component failed because the deformation or deflection is too large. Okay. And there is another tools to evaluate the deflection. Okay. So we learn also about this. Then next, we also have buckling. What is buckling? So if you push the ruler from the top, down, then the ruler will deflect, even though the loadings is small compared to the yield stress of the material. Even we made the ruler from the steel, which has higher strength than plastic, but because the geometry is too slim, then even though we apply small loadings, it can deflect the rulers. So this is the new phenomena that we will not find in the stress analysis. So that's why we learn about buckling. Okay. So now, after we develop all those competencies, then we can have the tools to design the machine components. That's the mechanics of material.